Hello everyone. So today we will complete the lecture about artificial pacemaker. Last time فإذا هون وصلنا للبارت يلي عم تحكي عن الاسynchronous pacemaker. فإذا بس كتذكير لما بقول asynchronous pacemaker فإذا this artificial pacemaker it delivers electrical stimulus at a selected rate or at a uniform rate regardless of what is going on in the heart. فإذا بغض النظر عن ال cardiac activity عن what's going on in the heart, it delivers this pacemaker, this asynchronous pacemaker delivers stimulus at a fixed rate, at a uniform rate. The block diagram of asynchronous pacemaker is composed of a power supply, an oscillator, a pulse output circuit, lead wires and electrodes. فإذا مثل ما حكينا إنه الباور سبلاي هي just أو هي necessary, it's necessary to supply energy to the pacemaker circuit. The oscillator, the function of the oscillator, it establishes the pulse rate for the pacemaker and thus in turn control the pulse output circuit يلي هي provide the stimulating pulse to the heart. فإذا ال pulse output circuit it provides the stimulus to the heart and it provides this stimulus via the wires and electrodes. This is concerning the asynchronous pacemaker. فإذا هون كمان حكينا إنه we have constant voltage or constant current amplitude pulses. فإذا either the pacemaker may deliver constant voltage or constant current amplitude pulses. Constant voltage amplitude pulses in the range of 5 to 5.5 volt with a duration of 500 to 600 microseconds. Constant current amplitude pulses are typically in the range of 8 to 10 milliampere with a duration of 1 to 1.2 millisecond. The rate of asynchronous pacemaker range from 70 to 90 beats per minute. طبعا الليد وايرز عندن لازم يكون عندن characteristic انه they must be good electrical conductors. هذه أهم نقطة هون لازم نركز عليها. فإذا they must be good electrical conductors. Also they must be mechanically strong and they must be insulated to prevent noise or transients. Now let's talk about the synchronous pacemaker. So what's the difference between asynchronous pacemaker and synchronous pacemaker? Synchronous pacemaker is also called demand pacemaker. فإذا demand pacemaker it delivers the electrical stimulus only when needed. So the asynchronous pacemaker delivers electrical stimulus at a fixed rate, at a uniform rate. However, the synchronous pacemaker or demand pacemaker, it delivers electrical stimulus only when needed. I can say that the demand pacemaker is a kind of pacemaker or it's a specific programmed mode in a new generations, in new pacemaker generations. It's an automatic pacemaker. So we can say that the demand pacemaker, it's a programmed mode. It has a programmed mode and it's considered as automatic. So when activated, it adjusts the stimulation of the heart based on the demand of the blood circulation system at any given time. So based on the demand of the blood circulation system at any given time, this pacemaker, this kind of pacemaker delivers a stimulus to the heart. This synchronous pacemaker it detects or the patient's electrical activity. It monitors the patient electrical activity. It senses this electrical activity and delivers the stimulus when needed. Uh, if the stimulus is not needed, so it inhibits the pacemaker from firing the electrical stimulus. This pacemaker consists of a timing circuit. It also consists of an output circuit and electrodes, just like the asynchronous pacemaker. But here, it also has a feedback loop. It also has a feedback loop. So here, the demand pacemaker it searches for the intrinsic cardiac activity. If the cardiac activity doesn't, or if the pacemaker doesn't detect or sense a beat within a specific interval, it will deliver a pace. So it will deliver a pace impulse. It will deliver a stimulus. When it detects a beat, it will reset its timer and continue the search for cardiac activity. So this is how the synchronous pacemaker works. So let me repeat. So after each stimulus, so here the timing circuit and the output circuit here deliver the stimulus to the heart. After each stimulus, this timing circuit resets itself, and it waits the appropriate interval to provide the next stimulus and to generate the next pulse to the heart. However, here, if during this interval a natural beat occurs in the ventricle, if a natural beat occurs in the ventricle, this feedback circuit detects, so it detects the QRS complex of the ECG signal from the electrodes, and then it amplifies this QRS complex by passing the signal through an amplifier. The signal is then used to reset the timing circuit. So this is the case when the circuit detects a beat, a natural beat. Also, if the heart beats again, before this stimulus is produced, the timing circuit is again reset. And this process is repeated. It repeats itself. And this is the case when the heart is operating normally. So if the heart is operating normally, that is, it generates ECG signals or a QRS peaks at a normal rate. So no need here for the for the generation of electrical stimulus. However, if a heart block occurs, the pacemaker or this circuit takes over and stimulates the heart at the fixed rate of the timing circuit. This is how this demand pacemaker work. فإذا هون عندنا timing circuit and output circuit. A timing circuit he generate the stimulus. في حال انه الهارت is working normally يعني ال heart rates are generated in a normal way يعني عندنا QRS peaks or ال PQRST segments are generated normally يعني مثلا كل 60 let's say every 60 second a beat is generated فإذا بهالحالة no need for artificial stimulus بينما إذا في عنا بلوك إذا عيصير في عنا بلوك كل وقت كل فترة معينة هيدي السيركت المفترض إنه it must detect this block شو يعني إنه it must كيف بدها تعمل detection لهيدا البلوك أكيد هون بتعمل measurement للinterval between two QRS peaks فإذا ال distance أو ال interval of time between two QRS segments إذا كان مثلا greater than 60 second فإذا بهالحالة the heart skip a rate a beat when the heart skip beats فإذا we need to generate artificial beats we need to generate artificial stimulus via the timing circuit فإذا هيدي السيركت بكل بساطة إنه بتعمل detection بتعمل monitoring للهارت بيتس لل ECG signal إذا في عنا block it will generate a stimulus else the circuit we have a reset circuit here that reset the timing circuit to stop this generation of artificial stimulus هذا هو مبدأ الديماند pacemaker. Some details are illustrated here in this slide. Now we have another system which is called the Atrial-Synchronous Pacemaker. طبعا مثل ما ممكن شايفين هون بالبلوك diagram انه ال Atrial-Synchronous Pacemaker is more complicated. It has a circuit which is more complicated. ولكن هذا pacemaker is designed to replace the blocked conduction system of the heart. So if we have a block in the conduction system of the heart, we can use what's called the atrial-synchronous pacemaker. شو بيعمل هذا atrial-synchronous pacemaker? It detects this circuit يعني عم نحكي عن هذه السيركت it detects the electrical signal corresponding to atrial contraction بس قول atrial synchronous pacemaker يعني أكيد هون عم نعمل detection لل atrial contraction atrial contraction يعني هي ال P wave of the ECG we detect this P wave by an electrode what's called the atrial electrode which is implanted in the atrium and this atrial electrode we use it to it uses appropriate delays هنشوف هلا بعد شوي نحكي عنهم to activate finally a stimulus pulse to the ventricles. So we have an atrial electrode that measures the atrial contraction or the P wave of the ECG. This electrode is implanted in the atrium. This electrode uses appropriate delays to finally activate a stimulus pulse to the ventricle. So at first, V1 here, the voltage here, is detected by this atrial electrode. طبعا هون ال V1 يعني حتكون هي ال pulse that corresponds to each beat. The atrial signal is then amplified using an amplifier. It passes through an amplifier. Then passed through a gate to a monostable multivibrator. This gate ممكن تكون a transistor. This gate is a transistor. Now the multivibrator, this multivibrator here, the monostable multivibrator 120 millisecond delay. هيدا multivibrator gives a pulse V2 of 120 millisecond duration. طيب شو هي هيدي الديوريشن ال 120 millisecond؟ هي corresponds to the approximate delay of the AV node يلي حكينا عنه بأول الشابتر. فإذا هيدي ال 120 millisecond duration هي ال approximate delay of the AV node. هلا remember here that this delay لما بقول أنا AV node delay it ensures that the atria have ejected their blood into the ventricles first before the ventricles contract. فإذا هيدا الديلي لحتى نتأكد إنه الاتria eject the whole blood into the ventricles before the ventricle contraction starts. فإذا this monostable multivibrator gives a pulse V2 of 120 millisecond duration. We have here another monostable multivibrator which give a pulse duration of 500 milliseconds. Then we have another monostable multivibrator giving a pulse duration of 500 milliseconds. This is also triggered by the atrial pulse. Then it produces V4, a voltage V4, which causes the gate to block any signals from the atria. Then V4 causes the gate to block any signals from the atrial electrodes for a period of 500 milliseconds following contraction أكيد. شو بيعمل هيدا الشيء؟ فإذا this eliminates any artifact caused by the ventricular contraction from stimulating additional ventricular contraction. فإذا نحن لما يصير في عنا بعدين هون after V2 لما عنوصل للventricular contraction هلا هيدي الventricular contraction ممكن تعمل trigger لنيو stimulus ونحن بيغنى عنا هيدي الستيمولس منا بحاجة لإلها هيدي حتكون artifact. فإذا to eliminate this artifact caused by the ventricular contraction from stimulating additional contractions we can use here a monostable multivibrator that give a pulse duration of 500 milliseconds. So we have two monostable multivibrators. Here V2 then is used to trigger another monostable multivibrator of 2 millisecond duration. So it acts also as a delay, allowing the ventricular stimulus a pulse V3. It allows the ventricular stimulus pulse V3 to be produced 120 milliseconds following atrial contraction. This is just a delay, small delay 2 milliseconds. فإذا بعد هيدا الفايبريتر عندنا هون voltage V3 حيصير بعدين عندنا هون output circuit حيكون عندنا هون بالبلوك diagram ليش استعملوا هون شو شغلتها هيدي الاوتبوت circuit it controls the ventricular contraction يعني the function of the output circuit is to control the ventricular contraction وطبعا ال V3 controls the output circuit والاوتبوت circuit it applies the stimulus to appropriate ventricular electrodes وبعدين حيكون في contraction. This is concerning the Atrial-Synchronous Pacemaker. فإذا هدول المونostable multivibrators هني to provide delays. Some discussions are illustrated here in the slides. Okay. This is concerning the atrial-synchronous pacemaker. لازم تعرفوا هون فإذا ال components of the block diagrams, the function of each component will function of this atrial-synchronous pacemaker. Rate responsive pacing, this is another method. فإذا نحن شفنا قبل إنه synchronous pacemakers can meet some of the physiological demand for variation in heart rate and cardiac output. ولكن هدول ال synchronous pacemaker هدول ال devices still do not replicate the function of the heart in a physiologically intact individual. طبعا هن بيعطوا pulses, they generate pulses and they generate impulses, generate stimulus to the heart to beat in a normal way. ولكن السينكرونس بيس ميكر يعني ما كتير انه replicate بينسخ الفانكشن، يعني بيشتغل مثل الهارت 100%. بعد في functions ما بياخدنا بعين الاعتبار. مثلا if the body or if the patient, if the person do activities, if he runs, if he walks, if he do sports, فإذا the demands of the body during stressful activities such as exercise cannot be fully met by these pacemakers. فإذا هدول السينكرونس pacemakers بيشتغلوا كتير منيح في حال إنه the patient is at rest and he's not doing any high levels activities. He's not doing any exercises, running, walking, or else. طيب فإذا هون نحن بحاجة لنطور هيدي البيس ميكر ونزيد عليها functions, new functions. أكيد هيدول الفانكشنز حيكونوا monitoring functions، يعني لازم ندخل على السيستم sensors، وهيدا السنسورز it monitors the beating of the heart، وبعدين على اساس البيتينجز، على اساس الاي سي جي سيجنال generated، على اساس number of beats let's say per second، البيسميكر بيعمل generation لstimulus. So we can use a sensor here. A sensor can be used to convert the physiological variable in the patient to an electrical signal that serves as an input to the timing circuit. Look, فإذا هون على الانبوت of the block diagram حيكون في عنا acceleration sensor for example. هيدا الاكسلريشن سنسور شو حيعمل؟ فإذا هيدا أول شيء sensor can be located within the pacemaker itself أو it can be located at some other point within the body. الأكسلروميتر for example هلا فينا نستعمل many types of sensors could be used. L'accelerometer is an example of such sensors. It can be used to control the pacing rate depending on the patient's activity. Okay, فإذا this is the function of the accelerometer. فاذا البلوك دايجرام هيدا اللي هنحكي عنه نحن هلا طبعا الريت ريسبونسيف بيسنج is programmed to control the heart rate on the basis of the physiological variable that is sensed. Physiological variables that is sensed with the accelerometer, for example. فإذا we can measure the acceleration. نعتبر إنه acceleration تعطينا information عن نشاط الهارت. كمان many different physiological variables could be used to control rate responsive pacemakers. ما ضروري بس الاكسلريشن، ممكن يكون عندنا other physiological variables. طيب the block diagram of this rate responsive pacing is composed of the following steps or of the following blocks. فإذا here we can use an acceleration sensor to measure the activity of the heart. This acceleration sensor فإذا هو acceleration sensor it provides a signal. هذا السيجنال is band pass filtered to minimize noise أكيد, then integrated to yield the activity estimate. هلا هون عندنا فإذا band pass filter accelerometer it gives us a signal. This signal is band pass filtered to minimize noise, then it passes through an integrator. طبعا integrator بس أقول integrator it performs a mathematical operation of integration with respect to time. يعني ال output voltage is proportional. أكيد ال output voltage here output of the integrator is proportional to the input voltage integrated over time. So its output voltage is proportional to the input voltage integrated over time. We have here a control algorithm for the timing circuit, which determines the pacing rate based on the measured activity. As at the output of this block diagram, we get the pacing rate. قديش لازم يكون ال pacing rate. فإذا بنحصل على النتيجة حسب ال measured activity by the accelerometer. This is concerning the rate responsive pacing. فإذا rate responsive pacing I can say that it replicates the function of the heart. يعني it measures the activity, the heart activity, and according to the heart activity, it delivers the pacing rate, the necessary pacing rate. This is concerning the pacemaker. فإذا شفنا هون different systems: rate responsive pacing, Atrial-Synchronous Pacemaker, demand pacemaker, and asynchronous pacemakers. Thanks for listening.